Welcome to the Deep Dive. Today, you've shared some really interesting material outlining the basics of space travel, how we actually get off Earth, what keeps spacecraft going, and just the variety of vehicles involved.
Yeah,
Our mission today, to kind of break down these fundamentals, so everyone gets a clearer picture of how it all works.
exactly. We're digging into the core principles based on the sources you gathered that let humanity explore beyond our own planet.
Okay, let's start with the really big one.
Yeah.
Launch. It's all about rockets, isn't it? These massive things that literally push spacecraft out of Earth's atmosphere and into space.
Mm-hmm.
Seems obvious, but the level of sheer planning and coordination needed for a safe, successful launch is just mind-boggling. All the timing, the systems checks.
You're absolutely right. I mean, fighting Earth's gravity takes just immense force, and the calculations for the trajectory, they have to be unbelievably precise. Without that huge initial push, well, we're just stuck here. It's the very foundation.
Right. And once we are up there,
Okay.
we can get into orbit around Earth. It's
Yeah.
clever how it works, isn't it? You get going fast enough and you basically keep falling around the planet instead of back down onto it.
Exactly.
Satellites, the space station, they're all using these orbits constantly. It's like this perpetual balancing act with gravity.
It is precisely that. It's achieving that equilibrium between gravity pulling you in and your forward momentum keeping you moving sideways. That balance makes everything possible, from, GPS and weather forecasting to long-term science up there.
Okay, so how do these spacecraft actually, like, steer and move once they're out in the vacuum? The material talks about propulsion.
Yeah.
We've got the chemical rockets, the classic fiery engines essential for launch, and big direction changes.
Right, the big burns.
But then there are these other things, electric propulsion, like ion engines. They're supposed to be super efficient for, like, really long trips. What's the main difference there?
Well, chemical rockets give you a massive amount of thrust, but they burn through fuel really quickly, great for escaping gravity or making a fast major course correction.
Okay.
Ion engines, on the other hand, they use very little propellant, but they accelerate it to incredibly high speeds, so you get this very gentle but constant push. Think sprinter versus marathon runner, different tools for different jobs.
Okay, that makes sense, especially for interplanetary travel.
Yeah.
Going to Mars or Jupiter or even asteroids. That sounds incredibly complicated. It's not just point and shoot, is it?
Not at all.
The notes emphasize the need for super precise trajectory math and, like, constant adjustments. And this concept of gravity assists using a planet's gravity like a slingshot to speed up. That's pretty smart fuel saving.
Oh, absolutely. It's crucial for deep space missions. By timing a flyby just right, a spacecraft can essentially steal a tiny bit of the planet's orbital energy. It gives you a significant speed boost without burning precious fuel, like cosmic billiards, yeah.
Okay, cosmic billiards? I like that. Now, what about getting to these other worlds, especially if they have an atmosphere? The source mentions entry, descent, and landing EDL as a huge challenge.
Yeah.
You can't just, like, fly down and park, right?
Definitely not.
You need different tools, parachutes, thrusters, firing backwards, retro rockets, even those bouncy airbags we saw on Mars landings. Seems like every destination needs its own landing plan.
That's right. Hitting an atmosphere at orbital speeds creates intense heat from friction, so you need robust heat shields first. Then EDL is this whole complex sequence slowing down from thousands of miles per hour to, hopefully, a soft touchdown. It's a massive engineering problem every single time.
The overview also covers space stations, like the ISS. These are basically orbiting outposts, places for astronauts to live and work. It's pretty amazing what they achieve up there, the science and teamwork.
Yeah, the ISS is a phenomenal example, not just for the science understanding microgravity, human physiology in space, but also as a symbol of international cooperation. It's really teaching us how to live and work off-planet for long periods.
And then there are the robots, uncrewed missions. The source really highlights how vital these robotic explorers have been, sending them to planets, moons, asteroids, places maybe too far or dangerous for humans, at least for now.
Absolutely. There are scouts, our remote sensors across the solar system. Think of the images from Mars rovers or data from probes orbiting Jupiter or Saturn. They've completely revolutionized our understanding of our cosmic neighborhood, sending back just invaluable data.
Looking ahead, it feels like space travel is maybe on the cusp of some big changes. Reusable rockets are a big one, obviously. Space tourism is becoming a thing. People are talking seriously about bases on the moon, even sending crews to Mars.
Yeah, things are definitely accelerating.
Plus, there are these more futuristic ideas being researched, nuclear propulsion, maybe even space elevators someday, solar sails. What stands out most to you from that list?
For me, the reusability aspect is probably the biggest game changer right now. Companies like SpaceX have shown it's possible, and it has the potential to drastically lower the cost of getting anything to space. That just opens up so many more possibilities for science, for commerce, for exploration.
So, pulling it all together from this overview, it's clear space travel is just this incredibly complex thing. It pulls in engineering, physics, math. It's a real testament to human curiosity and ingenuity, isn't it?
It really is. From understanding the basic laws of motion that Newton figured out centuries ago to developing these incredibly advanced materials and propulsion systems today, it's a constant push, always learning, always reaching for what's next.
Okay, final thought then. Considering all these potential future steps, cheaper access with reusable rockets, moon bases, Mars missions, maybe even those wilder ideas like nuclear engines or solar sails, what single future development in space travel do you personally find the most compelling and why? What gets you most excited?